This is actually a revisit of an old video I did back in video 106, where I talked about the BackgroundWorker callback delegate. And essentially I had a code where I checked a specific text box, and I said if the invoke is required for that text box, then instantiate a delegate. And the delegate actually was the same function as the one we were in, and then re-invoke this function as a delegate and pass the parameters that were passed to the original function. And the way the delegate was defined is void with an int parameter, and if an invoke wasn't required, which was the case in the second call when I was invoking it, it no longer needed an invoke because it was being invoked. I basically just set the parameter to the text box and then did an update of the text box. So if we look at the actual code, this was the function I wrote, report progress text box, with a int ix, so it matches the delegate function signature. And I say if the invoke isn't required, then just set the parameter, convert it to a string, to the text box and update. But if it is required, instantiate a delegate with this function, the same function that we're already in, as the actual function behind the delegate, and then invoke this delegate with an array of objects that essentially is a technique for passing any number of parameters. I'm pretty sure you could say ix, comma, name, comma, and so on, and have a number of parameters. And then within the do work, which runs on a different thread than the GUI, so you can actually write to things like text boxes and check boxes and radio buttons and so on. I have a call to this report progress, so it has a tick-tock motion. Basically, the first time it called, invoke is required, and it instantiates itself as a delegate and invokes itself, and then this calls itself a second time, and this time invoke isn't required because we are using an invoke, and it just sets the text box. But this is a very complicated way of doing it, and I think it gave the impression that you're going to need a different function like this for every single control you have, and you don't. I wanted to clarify that with this video. So in this alternative technique, I just have the delegate reference one function that's instantiated in do work and then invoked in do work. And I don't even look at invoke required because I know invokes are required. I know that I have a bunch of different GUI controls, and I'm going to need to have a delegate that goes back and runs in a thread on the same thread as the GUI. So I don't bother to check invoke required at all. And the steps in this technique is I create a BackgroundWorker component which I call BGW work with GUI in good Hungarian notation. And then I create the function that actually interfaces with the GUI, which is just a regular function. And then I define a delegate which is the same function signature as the function, which is a void with no parameters. So once I've defined that delegate, I write the BackgroundWorker do work code, and I instantiate a delegate called d_myDoWork with this function passed as the defining function for that delegate. Actually, you can have a whole list of functions in a delegate. In effect, a delegate is a list of functions, but we only have one, which we define with the instantiation. and then we invoke this delegate, which allows us to run the function on the same thread as the GUI, whereas the do work is running on a different level. And finally, we write the button code itself, which does the run worker async and invokes the background worker, specifically the 3 background worker methods, one of the major one of which is do work, the one that runs on a separate thread. So in order to actually implement this, we drag over the background worker component to anywhere on the form. And of course it doesn't actually appear on the form, it appears in the component tray at the bottom of the IDE. And we give this background worker the meaningful name of BGW work with GUI. And then in the form code, the code behind, we put the function that actually interfaces with the GUI, which is fairly long because I have a number of different controls this interfaces with. In fact, that's sort of the point, that you can have a lot of controls with one delegate. And then in a global area, we define the delegate with the same signature as the actual function, a void with no parameters, void return with no parameters. And then in the IDE form design, we select the background worker and go over and select the events. And there's 3 events: do work, progress changed, and run worker completed. And progress changed and run worker completed actually both run on the same thread as the GUI, but they have limited capabilities, extremely limited. So what we want to do is define a do work. So double click on that, and then within that we want to put the code that instantiates the delegate we just defined at the top of the form with the actual function that we defined that interfaces with the GUI in the delegate list, the only thing in the delegate list really. And then we use this.invoke, which is a predefined form method, to invoke the method that interacts with the GUI. And you notice within the function I have a number of sleeps, so things happen a little slowly. You can actually see them happening. So we can see the progress of the background do work, which is sort of like a simulation of what do work is, which is doing something that takes a lot of time. So we don't want the system to hang because we're taking a lot of time and a lot of CPU energy. And then finally, within the event handler for the button, we invoke our background worker with BGW work with GUI dot run worker async, which starts an asynchronous thread running, specifically the do work thread. So if we save this and compile and run it, see the form comes up with 2 radio buttons which are mutually exclusive. So when the code selects this, it will unselect this. And then I actually changed the label on this to say post background worker checked, since all these will become checked. And I check these one at a time. And then within the list box, I'm going to list the lyrics to Dishwaller's Angels or Devils, which is a song for some reason lately I can't get out of my mind. So if we press the run background worker, you see the button switches and the label switched, and each of these get checked in turn, and then the lyrics appear with half a second pause within the list box. So the technique does indeed work. You can just have one call to single delegate function which does all the interaction with the GUI. You don't have to have a call for every single control on the form. But this raises another question. Can you put the heavy lifting code in the invoked function, in the regular function that runs in the same function with the GUI? And weirdly, the answer to this seems to be yes. It's almost as though, because there's a two threads, the system is really delegating it to the background thread and delegating the GUI interaction to the foreground thread. And I know this from testing because the old code I wrote hung up the whole system. It not only froze the running program, but it seemed to hang up the computer as well. All I could do was bring up the task manager and cancel the program in order to get the computer working again. But this new code with the revised technique, so far, even with the heavy lifting code in the invoked function, works great. You know, it works perfect. And it somewhat bothers me that the invoked function will run even with the heavy lifting code in what should be the foreground function. But as I say, I think that's because there's two threads and the system itself is delegating the slow stuff to the background thread and the GUI stuff to the foreground thread. But I'm going to continue doing testing, and I might have to do some revision where we move some code from the foreground thread to the background thread if, you know, I totally stress tested and have, you know, like hundreds of really huge files and see if that manages to hang up. But so far I've done extensive testing and it seems to work. Well, I hope you enjoyed this video and learned a lot, and I'd appreciate it if you'd subscribe.